Now that you've had a chance to read the chapter on interpreting instructional research, I wanted to bring up some of the key points. First of all, there are a wide variety of research journals out there, um, probably literally hundreds of them. And within these, you'll find all kinds of research studies. And the focus of our discussion this week will be on the particular body of work that points us to research-based best practices for designing e-learning. And through that analysis, there are 9 different principles that we'll be discussing. But I wanted to just give you links to a few of the journals. Feel free to look these over. There's lots more. I wanted to talk a little bit about instructional research categories. And just as a precursor to this, those of you that have had the research methods class in the graduate program, this will make a lot more sense to. Those of you that haven't had that class too, this is probably a little bit going to be very abstract. I apologize for that, but I think it's important for you to have a little bit of a background in understanding how instructional research is done and where these research-based principles I'll be talking about come from. Because they're not just made up, they're based in actual results. Typically, in instructional research, we can compare instructional methods. For example, does real-time writing on whiteboards impart better learning than PowerPoint displays? So that might be an interesting research methodology to study. Another would be comparing instructional environments or learner characteristics. In this case, we might keep the same instructional methods but change the group of learners to see if there's a difference. The question answered is, when does the instructional method work best? And so, for example, does asynchronous instruction provide the greatest learning gains for poor readers? In this case, we might take the same asynchronous instruction and have a group of what we would call poor readers and a group of what we would call excellent readers, and see if there's a difference in the instructional outcomes, or at least the gains, let's say. So 2 kind of categories of research design can sort of fall into these 2 categories. Instructional research design is typically done in this way, though there's variations to it, but these are the general characteristics. You typically have 2, but sometimes more, randomized learner groups. And in really good research, we would have a control group and a treatment group. The treatment group would be the one that receives the actual variable that we're interested in measuring. Why do we randomize? Well, that's to control for unforeseen characteristics that might impact learning outcomes. For example, if we were to take, and this is often done, if we were to take a group of college students and test them for a particular instructional method, and let's say we get a positive outcome, I don't know, say, whiteboard writing worked better than PowerPoint slides for college students under certain conditions. And then could we then extrapolate that and say, well, that would work for grade school students? Problem with that would be that college students as a group have very different characteristics than, say, grade school students. College students had to pass an entrance exam. They had to have a certain grade point average. They're more mature. There's all kinds of things we could think about. But if we completely randomize a group, it includes grade school students, it includes college students, it includes different ethnicities, males and females, different socioeconomic backgrounds. I mean, imagine that. We have a completely randomized group, and that group is large enough. Then we could extrapolate the outcomes to everybody. And anyway, that's the idea. It's an important concept and something that you should look for when you read instructional research. To what degree was the group randomized? And all right, the next point is typically one feature is tested as opposed to multiple features. It's a little bit like troubleshooting. You can't change two different things and then understand which thing made the difference. In a troubleshooting procedure, we kind of have to change one thing at a time. So typically one thing is looked at in the instruction. The typical process for instructional research is the pre-test, post-test, and basically a pre-test is given to test the group's knowledge or skill level in a particular area. The instruction is applied to the group, and then finally a post-test is given, and we look at the difference between the pre-test and the post-test. And you would hope the post-test would show learning gains, and the pre-test then, the instruction rather, would then have had an impact. And then we measure to what degree. The statistics that are used, and again, I apologize for those of you that haven't had statistics and research methods yet. You'll learn about this later then, but we want to compare mean scores with a t-test, typically, some kind of t-test. There's variations of these, like the analysis of variance, but typically instructional research statistical analyses fall around the t-test. And I'll explain just a little bit about the t-test. Typically, the outcomes of the scores of a pre-test and a post-test are measured along a normal curve. And essentially what the normal curve shows is the most common score, and then the scores that fell above the most common score, and the scores that fell below the most common score. And you end up with a normal curve. And the normal curve then has standard deviations. And the standard deviations are the degree to which the outlying scores deviated from the mean score. Without getting into much more than that, this is the key statistical basis around which we draw conclusions. So a little bit about the t-test concept then. What we are looking for is the two groups that we would be testing, or the two different testing methodologies, and we would have two different normal curves. Let's say, for example, going back to the whiteboard writing versus the PowerPoint slides. Let's say that we took the groups and we applied the instruction to the whiteboard writing, and the normal curve fell here. So the score was right here, but then for the PowerPoint slides, the score fell here. So we'd have two different normal curves. And then the question becomes, well, is there a significant difference between these? Significant enough that we can say that there was definitely an effect that occurred between whiteboard writing and PowerPoint slides. And that's where the probabilities come in. And basically, we're saying, if we have this difference, what is the probability that there's a difference between the means when there's really no effect at all? This is counterintuitive. It's part of the whole understanding the t-test. But basically, is the difference due to chance, or is there actually a difference? And so we usually apply some sort of a level of difference in order to show that. And that's where the t-test comes in. So is there a significance threshold with a 5% chance? So that is typically signified with a p, which stands for the probability. And so you might see in research studies a p of 0.031. So that's showing the two normal curves. Based on the statistics, there's a 3.1 chance that the difference between these means is due purely to chance and not to an actual effect. And that would be a very low probability, and we would be able to draw the conclusion that it's very likely that that difference is due to the actual instruction that was given. There's two types of t-tests in instructional research. Typically, you have what's called a two-sample t-test, and that's where the mean and variability, or standard deviation, is compared between two different groups of students. And so, for example, was there any difference in learning between group 1 and group 2? There's also what's referred to as a paired t-test. And that's where we compare the mean and variability of a single group receiving two different treatments. So it's a single group, but that same group receives two different treatments, and we measure the outcomes between the two. So, for example, Did the group rate instructor A better than instructor B? We could come up with two different normal curves for each one and see if there's a significant difference between the two. So paired t-test versus a two-sample t-test. And then finally, and your book goes into, or the chapter that I gave you to read goes into some detail with this, and it's a very important element of understanding the statistics, even if you don't completely understand the t-test. Understanding the statistics that come out of instructional research. And that is the effect size. And essentially, it is a significance measure. And it's done mathematically, and I've given a visual of the difference here, and hopefully this will make sense to you, even if you haven't studied the statistics. But let's take this, let's take this one over here first. So what we have is, let's use our whiteboard versus PowerPoint slide test that we did. And this is the whiteboard, and this is the PowerPoint slide, and the pre-test, post-test gains. So here is the whiteboard, as I said, and it's actually a lower. The mean is a lower score, and with the PowerPoint slide, it's a higher score. And then we have a standard deviation that falls around that. You can see visually that the majority of the group members fell inside of both of these. There's very few that fell outside each side. So the effect size essentially measures how many of these students actually gained or did not gain based on the test. And that ends up having a lot to do with the standard deviation. So if you take a look over on this side, you'll see that the standard deviation is much lower. So the vast majority of students who got the whiteboard, I think I said this was the whiteboard side, benefited, whereas the vast majority of students on this side, or didn't benefit, I should say, the vast majority on this side benefited. And that's shown mathematically by taking into account the standard deviation. So what we do is we subtract the means, the mean scores, gains, and then we divide that by the standard deviation, and we end up with what's called an effect size. We could do the same thing over here, where the standard deviation is much wider, as you can see, and in this case, the effect size is much smaller. So I think the typical instructional researcher looks for an effect size of 1.0 as being really significant. Now, both of these curves would have a statistical probability of less than 5%. So a researcher desperately wants to show that their research is effective, and they might say, you know what, we did see a statistical difference, but it doesn't mean that it was really a worthwhile difference. So I hope that makes sense to you. It's an important aspect of instructional research interpretation.